So when we look at this one, how many answers are we going to get? Good. Why 4, everybody? Why is it 4? The highest power. It's called the degree. Okay. So we are going to get 4 answers. So last time, and later on this block, I'm going to have you all come up here and get a calculator so you can practice playing around and typing them in. This is your X button, this variable key right here. It says link above it, but it says X, T, theta, and that's what you hit to get X. I'm going to go to Y equals. I'm going to clear out that. And I'm just going to type in this function. So for right now, I just want you to watch. It's X to the 4th plus 20x squared plus 64. You can hit graph, which is right here. But if the window is really weird, hit zoom. And do you remember which number on here I said would put it back to like sort of normal? Yeah, zooms in. Everything is kind of what it sounds like. But if you do zoom 6 standard, it'll put it back to a normal window. Now, we'll wait till it's done graphing. Where is it? It is there. We just can't see it. Why? Look at the equation. What about this equation should explain to us why I can't see it on this? It's up 64. So it's all the way up there. And if I changed the window, we'd be able to see it. But that's not really necessary because the point is we want x-intercepts. Now, we just said we were going to get 4 answers, but I don't see any there. That means all 4 answers are imaginary, which means this is useless to me. I will be honest with you. This is like the most commonly missed type of question on the test because people lose their collective mind when the calculator won't help them anymore. There's no number that can go in the little box. There is no synthetic division. You are back to basics. We're going to factor this and set it equal to 0. You can't use the calculator. I get people write me paragraphs. Ms. Cole, I don't know what number to put in the box. Ms. Cole, my calculator didn't show me anything. Ms. Cole, I don't know what to do. Factor it. How would you split x to the 4th? Good. X squared and x squared. Now you need numbers that multiply to be 64. Wow. I didn't even have to talk you through that. As a heads up, they'll be perfect squares because I'm nice. Okay. It'll be 16 times 4. And then what symbols do you need? Plus. Good. And then you set each of these equal to 0 and work them out. X squared plus 16 equals 0, x squared plus 4 equals 0, and just keep going. Remember I kept saying that these problems are long. Just keep going. You keep going until you get your answers. Don't stop. So what would you do to start solving? Yeah, minus over the 16. And then square roots. So what do we get out of that one? X equals plus and minus. Close? 4i. Perfect. All right. And then do the same thing with this one. You would subtract over the 4. X squared equals negative 4. Square root. And you get plus and minus 2i. And is that a total of 4 answers? Yes, because it's positive 4i, negative 4i, positive 2i, negative 2i. And they're all imaginary. All right, so I'm just going to put the quiz review on this same video. That was just our warm-up. Now we're going to do our quiz review. So we're going to use this graph here to answer all the questions. Now, if you want to go ahead and put the arrows on the end, it is going to keep going. And so what do you think for domain? All reals. Hey, kiddos, the domain for a polynomial is all reals. That's the answer. Like, that's a freebie. Like, that is the answer on the quiz. It'll be all reals. Range sometimes isn't all reals. For example, don't write this on your paper, but like, say you got something that looked like that. Do you see how it would be like this peak and everything below? Like, you wouldn't get everything. This one, however, will be all reals. And why is that? Yeah. Up forever and down forever. So this one will be all reals. Range isn't always all reals though, so just keep an eye on that. All right, relative maximums. And see how there's like a maybe S there? You could have more than one. It's the top of the hill. So like it goes up, turns around, and comes back down. So do we have a top of the hill kind of point here? Yes, this one right here. Now, if you want to label, it's the point negative 4 comma 0. But how will I write it on my answer line? Perfect. Just flip that around. But if you want to label it, that's not a bad idea. I'm crazy about labeling. I label everything because most of math is about staying organized really more than anything else. All right, and then relative minimum is this one. So I'm going to label it. It's the point -2, comma, -6. But again, when you write it on the line, you just write it the other way. You're saying this is the answer at this location. And then increasing, decreasing, we're going to do left to right. More labeling. If you want to label this end -infinity and this end +infinity, because we're going to go left to right, you can do that. And then just read it left to right. Hey guys, what is the graph doing first? Good. Okay, increasing from -infinity to -4. And I don't mind whether you put brackets or parentheses on that. You just can't bracket an infinity or a negative. All right, and then we decrease from -4 to -2. It looks like an ordered pair, but it's not. It's an interval. And then we increase again. So I'm going to union on here. We increase from -2 to infinity. I do get people asking about this point. The graph increases and continues increasing. So it increases throughout that entire interval. So that little wiggle doesn't change that. All right. And then your limits. Limit x goes to -infinity of the function. That's the left end. Limit x goes to +infinity of the function. You guys this year have been really good about that limit notation. Sometimes that's a struggle for me to get people on board with that. I think you guys all wrote that on your tests the last time. Please be really careful with this though. And I try to look through them. You know how I start grading them as you guys turn them in? If people accidentally leave their paper like this and leave it blank, I try to catch it and give it back, but I can't catch them all. So it's a bummer if you leave this blank, all right? Where does your left arrow point? -infinity, and then the right arrow. All right, and then we're going to graph these ones. I did ask you to show the x and y intercepts because I didn't ask about the y intercept in the other problem. So we're just going to show both of them. Might make the graph look a little weird, but these look weird to begin with. They're like little doodles. All right, so your x intercepts would be -2, 0, and what else? 1, 0. Good. So -2 and 1. And again, I'm going to have you throw the y-intercept on there just for good measure, just so I can basically throw another point on the quiz. You get the y-intercept by plugging in 0. So we're just going to plug in 0 and see what happens. Ready? 0 plus 2. 2 squared is 4. So that first part is 4. And then 0 minus 1, -1. So 4 times -1 is -4. So that'll be right there. Again, I just threw that on there to give you another point for something. Okay. Now you have to graph these right to left, which is uncomfortable because everything else we do in life is left to right. If you're a left-handed person, this is your thing. All right. Do you see a negative out front? So the right side goes up. I usually just put a little arrow. However you want to do that, though, is fine. And then if it's a power of 1, you're going to cross straight through. 2 is going to be like a parabola. It'll bounce. 3 is a wiggle. Okay. So when we connect to 1, that's the factor with the 1 in it, guys. What are we going to do there? Go through. So just go through. Somehow I'm going to have to connect to this point. So that's going to look a little weird. All right. And then what are we going to do at the -2? Bounce. Good. So when you get there, just bounce off of it and go the other way. It'll look weird, but that's fine. Doesn't matter. It's a doodle. Let's just try it again. X-intercepts for this one would be 1, 0. And what else? -4, 0. And then I just threw the y-intercept on there to have another question on the quiz. You're just going to plug in 0 and see what happens. All right. So 0 minus 1 is -1. -1 to the third. So that's -1 times -1 times -1, -1. And then 0 plus 4 is 4. So again, we get -4. So I'm going to plot all of those. And then do you see a negative out front in the equation? No. So the right side again is going up. If there was a negative there, it would just go down. Right? When we get to the 1, what are we going to do? Yeah, squiggle. If you can't draw that or you struggle to draw that, do you remember what I told you to do? Yeah, write like squiggle or wiggle right next to it. Labeling. All right, so we're going to go through this point, and then what are we going to do at the -4? Yeah, go straight through. Good enough. That's whatever. I can try to make that look a little prettier, but you know, there we go. It's whatever. They're doodles. Hey, that one didn't look too bad. All right. And so that's stuff that you learned last year. That's stuff from Algebra 2. All right. And we're going to flip over. This is the new stuff. All right. So this one is synthetic division. What number is going to go in the little box? 3. 3 goes in the little box. Check if the countdown is in order. So is it in order or are we missing something? Missing 4. We don't have any x to the 4th. So it's going to go 2, 0, -17, 5, 6, -10. Now, for this one, is the remainder necessarily 0? No. I was just teaching you division. This was before we got into the whole find all of the zeros stuff. So the remainder is just going to be whatever. But remember me saying, because it's non-calculator, the numbers are going to stay manageable. So if you get it to spiral out of control and you get numbers in the like hundreds and thousands, find where you dropped a negative sign. That's like 9 times out of 10 what it is. It's not going to do that. Now you can't start until you do what? Bring down the 2. Multiply, add, multiply, add, multiply, add. So let's see. 3 times 2, 6, add 6. Do it again. 3 times 6, 18, add, you get 1. 3 times 1 is 3, add, you get 8. Oh, I gotta hold on.
Oh, no, sorry. I was talking myself.
Oh, okay. Well, I mean, this does go quick. If you blink, you kind of miss it. All right, 3 times 8, 24, add 30. 3 times 30, 90, add 80. So do you see how all the numbers were manageable? You didn't like have any major issues there. If you know your times tables, you're going to be fine. And then when you go to write out your answer, you start with 1 less than you had before. We had an x to the 5th. We divided out an x. So it's going to be 2x to the 4th plus 6x to the 3rd plus 1x squared. I'm going to stop saying it because that's annoying. But it'll be your countdown. And then how do you do the remainder at the end? Good. It won't be on the quiz, but does anyone remember what the x minus 3 is called? It begins with a D. Divisor. This huge thing is the dividend. Cool. All right, and then I'm going to have you do one that's long division. You'll be okay. Again, the numbers are going to be manageable. So this x squared plus 2x minus 1 goes outside. Is the countdown in order? Yeah, it is. Okay, so just copy all the other, just don't do a copy error. Those are a bummer. I left a line for the answer. You don't have to rewrite your answer though. Like, I actually don't know why I did that. I shouldn't have done that. You can just leave your answer right here. Please don't feel like you have to copy it over again. Okay. I'll be able to see it. I should just get rid of that answer line. All right. It's about staying organized really more than anything else. Compare the first two. You have an x squared. You want it to be an x to the 4th. What are you going to multiply? X squared. Good. Do not draw these lines on your paper. I'm going to have to erase them. It gets really cluttered, but I'm just trying to show you what to do. Distribute through there. It'll all line up. X to the 4th plus 2x cubed minus x squared. Again, that part usually goes okay. This is the tricky step because what do you have to do? Subtract. Give it a hug and subtract. Negatives are difficult, right? But most people will just go, oh, it's the opposite of what's there. First column cancels. This is really 4 minus 2. 2x cubed. This is really -3 plus 1. So -2x squared. Bring down the x. Do it all over again. It's a cycle. Cycling. Just do it all over again. So compare. You have an x squared. You want it to be a 2x cubed. So what would you multiply by? 2x. Good. You guys have got this. Again, don't draw these rainbows. I'm gonna have to erase them. I'm just trying to show you. Although we're at the point where almost no one is looking at me. You're all just doing the problem, which is excellent. Just make sure your answer's right. All right, that's gonna give you 2x cubed plus 4x squared minus 2x. Give it a hug and subtract. First column cancels. And again, just try to remember it's the opposite of whatever's there. So this is -2 minus 4. So -6x squared. Let me move this up. And this is 1x plus 2x, which would be 3x. You're gonna bring down the 8 and do it one more time. Whatever we get at the end of this one will just be the remainder. So what are we gonna multiply by this time? Yeah, -6. So you're gonna distribute a -6 into there. -6x squared minus 12x plus 6. Negatives are difficult. First column cancels. And whatever we get here is, we're just gonna tack it on at the end. It's a little bit more writing, but you don't have to do anything, all right? So this is really 3 plus 12. Good, so what do we get out of that? 15x, and this is really 8 minus 6, so plus 2. So again, you're done. You don't have to do any more work. You just have to rewrite this. You're gonna put plus this over this. It's your remainder over your divisor. So 15x plus 2 over x squared plus 2x minus 1. And again, you don't have to recopy that. I don't know why I left a line for the answer for that one. Like, please just leave that. That's fine. Because the more times you recopy, the more likely it is you're going to make a copy error.